Okay, let's get into it. Today, we're doing a deep dive on a very specific piece of hardware, the NTI E-5DB Environment Monitoring System, the EMS.
Right. And our mission really is to understand how this little box acts as the nervous system for a data center.
The nervous system, I like that.
Yeah.
It's this translator between the, messy physical world and all your carefully controlled digital infrastructure.
Exactly. Because your tech is basically useless if the room it's in floods or overheats.
So what are we looking at for a baseline, the base unit itself,
The basics are two internal sensors, temperature and humidity,
the essentials?
the absolute essentials. And then it supports 10 external connection points. 5 are digital inputs, think door sensors, contact closures, and 5 are for other configurable sensors.
So that's the foundation. It's really the firewall against
Yeah.
crippling downtime.
That's the whole point. It's watching for all the things you only think about when it's already a disaster. Water, power problems, intruders, smoke. Its job is to guarantee you can keep the lights on.
So when something does go wrong, the communication strategy here seems to be built on this idea that, failure is not an option.
Oh, absolutely. The redundancy is incredible. If a sensor goes out of range, you're not just getting one alert.
Yeah.
You're getting an email to 17 different addresses if you want. You're getting flashing LEDs, a siren, SNMP traps.
So there's no way to miss it. It can even make, voice calls?
Voice calls, SMS messages through an external modem. The whole philosophy is that if your main IT person is on a plane, the alert has to get to someone else. It has to escalate.
What fascinates me is the customization. It mentions you can configure up to 50 events, but then you layer those into smart alerts. What's that about?
So a smart alert isn't just the temperature is high, it's about combining things.
Okay.
It could be, for example, temperature high and UPS battery is active and the server room door is open.
I see. So that combination isn't just an environmental problem. That's a potential security breach during a power outage.
Exactly. It sends a highly specific, targeted warning to the right person, not just more noise.
And there are industrial models too, right, for more extreme environments.
Yeah, that's a key detail. They have models that work from -40 all the way up to 185 Fahrenheit. So you can put these things on a remote cell tower or a factory floor, not just in a climate-controlled room.
Which is important because this is where the system shifts. It goes from just sensing to, active control.
That's the next level. It doesn't just monitor the room, it monitors the network in the room. It can ping up to 64 IP devices.
So if a critical server or switch just drops off the network,
You know immediately. And then you
Yeah.
can act on it. You have 2 output relays.
right, to cycle power on external devices.
Yeah.
But wait a minute. It can also send SSH commands to soft shut down a machine. Why would you need that if you can just, cut the power with the relay? A hard boot is faster, isn't it?
It is, but that's a great question because it gets to the core of the strategy. The relay is brute force. You're cutting power. That risks data corruption.
Ah, I see.
The SSH command lets the system tell the machine's operating system, hey, things are getting too hot. You need to shut down gracefully. It preserves data integrity. It's the difference between pulling the plug and properly shutting down your computer.
That distinction is crucial. And it also plays nice with open source tools like Nagios and MRTG.
It does, which lowers the barrier to entry for smaller organizations. It means your environmental data can live right alongside your network data in the same dashboard.
Makes sense. And since this thing is preventing disasters, it has its own safety nets.
Of course. It has dual power supplies that switch over automatically, and you can get an optional internal battery that sends an alert when the main power goes out and another when it comes back.
And security is locked down. HTTPS, SSH, AES 256-bit encryption. It even supports XOUAE-H2 for things like Gmail, so your alerts are sent securely.
Right. And you can cascade up to 5 of them together, all managed from one web page if you're covering a large campus.
So if we pull this all together, this box is really a vital bridge.
That's the perfect way to put it. It bridges the gap between the physical world, the temperature, the water, and the digital operational world of network health and remote control.
So a final thought for you to chew on. Considering how deep this thing goes with alerting and network control, what other kinds of systems could use this? I'm thinking, beyond server rooms, maybe complex agricultural operations, medical storage facilities, infrastructure pipelines. Where else could this level of combined environmental monitoring and graceful network-based intervention be a complete game changer? Something to think about.